You have big plans for your weekend break when your teacher swoops in out of nowhere and drops a bombshell. You've been given a massive homework assignment to create a number guessing game in C++. Now, there are a few different possible reactions to this as you watch your weekend plans go up in flames. First, you might just cry uncontrollably, completely distraught that you have no idea how to approach such a problem. The other thing you might do is sit down at the computer and start typing out code that makes sense at first, but eventually you start to get lost in the mess of ins and outs and variables and function prototypes. If only there were a better way. When people first learn programming, especially a complex language like C++, they often think that the problem with learning it is the syntax, all the confusing error messages, or the wide variety of libraries you have to remember. But actually, none of those are the problem. The real problem that most beginning programmers have is that they've never been taught algorithmic thinking. Algorithmic thinking is the process of taking a big problem, breaking it down into smaller problems, solving each of those small problems, and then putting those solutions back together to solve the original problem. Let's look at another example to see how this works. Imagine that you've been assigned the task of writing down the instructions for making a peanut butter and jelly sandwich. If you think through this problem, you think, how do I break this up into smaller pieces? Well, the first step is to assemble some supplies. You're going to need 2 pieces of bread, some peanut butter, and some jelly. The next step would be to apply peanut butter to 1 slice of bread. And to do that, you'll need the bread and the peanut butter. You'll put those together, and you'll get a slice of bread with peanut butter. The third step is to apply jelly to the other slice of bread. So you'll take that bread, the jelly, put them together, and you'll get bread with jelly. And the final step is to combine those slices of bread, and you put those together, and you get a sandwich. And if it turns out there are a bunch of people that need sandwiches, you can look at this list, this algorithmic set of steps, and know that if you need to make more sandwiches, you need to repeat steps 2 through 4. So when you look at these steps, you can think of each step as if it were a function. You can think about your ingredients, your supplies, as variables, things you need to set up in order to solve the problem. The supplies you need for each subsequent step you can think of as inputs to that step, and the result of those steps you can think of as the output of that step. And of course, the idea of repeating certain steps you can think of as a loop. Sometimes, the outputs of some steps become the inputs of other steps. Let's apply the same process to the idea of creating a number guessing game in C++. The key to solving this problem using algorithmic thinking is to forget about the fact that we're trying to write this as code. Instead, just think of it as if you were writing the instructions to teach someone how to play a number guessing game. Well, step 1, we need to assemble our supplies. Now, for a number guessing game, we don't have physical supplies, we have mental supplies. We need to know the maximum number. Is it between 1 in 1,000, or 1 in a million, or 1 in 100? We need to have that maximum. We also need to know what our secret number is, what it is they're trying to guess, and we need to know what the person is guessing. This is the information we'll need to keep track of in our number guessing game. Once we've identified that information, our next step is to pick a random number. To pick a random number, we need to keep in mind what the maximum number is, and that will allow us to pick a secret number. So if the maximum number is 100, maybe our secret number is 45. Our third step is to ask the user to make a guess. So we say, hey user, make a guess. And the user does, and says, here's my guess. And then our fourth step is to evaluate the guess. We look at the secret number and the guess and say, do they match? Is the secret number higher or lower than the guess? Whatever the result is, we let the user know. And then we repeat steps 3 and 4 over and over again until the guess is the same as the secret number. This is our algorithm for the number guessing game. Now, to turn this into code, we will now remove our restriction and remember that we're writing this in C++. So the first thing we're going to do is look back at step 1, and we can think of step 1 as the main function. Now our maximum number we're going to set at compile time when we write the code. That's not going to change when the program's running. So we can make that a const int, and we'll just call it max number. The secret number, even though it's not going to change while the game's being played, we don't know it when the program first starts. It's something the program has to set, so we can't make that a const. We're going to set that to be secret, and then guess is definitely going to change throughout the game, and so we'll just make that an int called guess. Now our second step is to pick a random number, we said. So to pick the random number, we need the maximum number, which we are calling max number, and the output of this process is secret number, which we're referring to as secret. Knowing this information and knowing the types of those variables, we can go ahead and write down the function signature for that. Int pick random number, where the input parameter is an int called max number. We can repeat this process for step 3. Get user guess, we said we're just going to ask the user a question. So there's no information we need to provide as the input. The output is going to be the guess value, whatever the user guesses. So our function signature for that is a function called getGuess that returns an int and takes no input parameters. Our fourth step, we need to know the secret number in the guess, which we have variables for. Since this step doesn't return a value, it just tells the user something, we're not going to have an actual output value. So our function signature will be evaluate guess, taking a parameter of guess and secret, and with a return type of void, which means we're not returning anything. And then finally, our loop says we're going to repeat until guess is the same as secret number, which in our context is repeating until guess is equal to secret. Now, once we have all of this information, we can look at those functions that we just wrote down, and we can put those right at the top of our program as our function declarations. So our next step is to create the definitions for each of those functions and then connect them all together inside of main. So our first function was pick random number. This one's fairly easy. We're just going to use a very basic random number selector, and there are much better and robust ways to do this, but for learning about algorithmic thinking, this is perfectly fine. We're going to get a secret number that's going to be random up until the limit of max number, and then we're going to return that value at the end. Our second function to get the guess, we're going to initialize a variable, print out a prompt, get the user to type something, and then return whatever they type in. Once again, very basic. We're not checking for errors. We're not making sure they type in any numbers. This is just to demonstrate the simplicity of the algorithm. The third function, evaluate guess. We take the guess and secret and we compare them. If guess is less than secret, we let the user know it's too low. If it's greater than the secret number, we let them know it's too high. Otherwise, we tell them, hey, great job, you got the secret number. For our main function, first we need to make sure we're including all the right libraries. Since we're going to be printing stuff and getting input, we need IOStream. Since we're going to be getting a random number, we need random. And later on, you'll see that we're going to need the ctime library as well. We put our function declarations up here at the top, like we talked about. And then the very first thing we do in main is use this srand function. This, if you've never seen this before, just initializes the random number generator. There are a couple of different ways to write this. Sometimes you'll see instead of null pointer, people will say null or 0, but this essentially says every time you run the program, you want a different set of random numbers. Next, we create our variables that we're going to use. We set our const max number to 100, because that's going to be our upper limit. And then we're going to set guess to be -1 to start out, and then ask for a secret number from our pick random number function, passing in the max number that we set earlier. The reason we set guess to -1 is because our start of our loop is going to say we're going to do this process as long as guess does not equal secret. And at the very beginning, we know that secret is not going to ever equal -1 because our pick random number function does not return negative numbers. And so that's a safe default value. So as long as the guess is not equal to secret, we prompt the user for the guess, they type it in, that function returns it, we store it in guess, then we pass that to the evaluate guess function. We are taking the output of one function, making it the input of another function, just like we showed with our peanut butter example. And then as soon as they get the guess correct, the loop is going to exit, and we're going to print the you win message at the bottom. Now, the details of this we went through kind of fast, but the important part of this video is not the implementation of these functions, it's the algorithmic thinking we used to come up with what functions we needed and how to connect them together. So we turn this in, our teacher is super impressed, flies off into the sunset, leaving us to finally enjoy our well-deserved weekend break. All thanks to the power of algorithmic thinking.